This question is binary number with alternating bit. So you're given a positive integer and then you want to check if there are two adjacent bits, will always have different value. So basically it's straightforward. You want to check, 5 becomes 101. You want to check whether the neighbor, this or this, the same or not, and you want to make sure they are different. If they are the same, you want to return false. So 111, the neighbor for this and this are the same, and this will return false because this and this are the same. So basically it's traversing from the beginning all the way to the end, and then you want to make sure you're comparing with I and I plus 1. That's it. Alright, so the first solution is going to using a string that convert the integer to binary string, and then I'm going to traverse from 1 all the way to the end, bit.length and I plus, and I'm going to check the bit char at I is equal to the bit char at I minus 1. If they are the same, you want to return false. Alright, if they are not the same, you want to return true. Alright, so this will be it, right? This is space, I would say it's constant. This will be a time, length of bit. So yeah, this will be the first solution. The second solution, you are converting to the bit value. So what's the current bit? It's going to be n multiplied by 2, right? And once I have the first bit value, I'm going to shift right by 1. Alright, and I'm going to traverse the rest of length until n equal to 0. Alright, when this is happening, since I got the first value and I shift already, I want to make sure does the next value is the same as the previous bit. If this is true, I want to return false. Else, I'm going to just update based on the based on the n. Based on the last value in the n. I'll shift the n right by 1, and then return true at the end. So yeah, let me go over this again. So imagine n equal to 5. So 5 for the bit is 101 for sure. So what I have for the current bit is 1, and I shift the n so it becomes 10, right? And then I'm going to make a conditional check. Does the bit 1 is equal to n multiplied by 2, so it's going to be 0. If this is true, I want to return false. If not, I'll continue. So bit, since it's false, I'm going to reassign the bit equal to what? Equal to 0, right? Equal to 0. I'm shifting the n from 10 to 1. So it's still greater than 0, and then I'm going to make sure this my bit is equal to n multiplied by 2. So bit is 0, and then the n is 1 right now, so n multiplied by 2 is actually 1. So they are not the same. I'm going to just keep updating the bit and n, and then the next iteration that will become n equal to 0, so you want to return true at the end. Let's do this. Alright, so this will be the solution. Let's talk about time and space for this one. Space is going to be constant. Time, this is time. It is actually what? You're shifting the n right by 1 every single time, so it's going to be log base 2n. So log base 2n. So a little bit efficient than the other one for sure. Alright, so if you have a question, leave a comment, and I'll see you next time. Bye.